In cryptography and network security, we have gone through IP security framework and architecture in the previous session. Now we are moving to its modes. So coming to the modes of IPSec, we have two types. So the two types of IPSec modes we are going to discuss in this session along with its headers. So there are two types of headers where IPSec mode is about to consider. The first one is the authentication header and the second one is ESP, encapsulating security payload. So we'll be discussing these four in detail in the IPSec modes session, right? So let us move with the modes concept first. So we have two types of modes, that is tunnel mode and the transport mode. So as we are seeing in the diagram, a transport mode will be directly connecting a host to the another host. So when we are connecting two hosts with a direct communication, then we say that mode is of IPsec transport mode. When we are connecting one system, one host with any gateway and any gateway to a host, or else a gateway to the gateway, or else to a router to the host. So this type of communications which are not host to host are called as tunnel mode communications. So the IP security will be provided security in two ways. One is with respect to the transport mode, that is directly from user A to user B. And the second one is between the different types of access points. So there we will be utilizing the tunnel mode, right? So these are the two types of modes which we are going to discuss now. So the tunnel mode, as we discussed just now, it will be concentrating from a user A to user B. Now, user A and user B will be directly communicating with each other. Thus, we will be sending a data. I mean, in the tunnel mode, we will be directly communicating with a gateway to the user or else end system to the gateway. So that will be in a different way, right? So we are not communicating directly with the system to system. So thus we need a new IP address generated. Instead, the original IP address will be packed together with the ESP concept. So now ESP and AH are utilized in both the modes, tunnel mode and the transport mode. The tunnel mode is directly with end system to the gateway, but not directly with host to host. So thus the major theme here is we will be concentrating payload, major concentration will be on the data security, right? Now, when we have data and when we have header to that data, this both we will be encrypting with ESP. So now ESP is nothing but we will be encapsulating, means we are encrypting the whole as a one block. Now after this, the IP address is as a hidden mode here, right? So thus we are going to generate a new IP header here. Now the IP header which is generated new one is not the original one. When an intruder comes in between and tries to see what is the traffic flow of your data, like to whom you are connecting like that. So they can't see the original IP address which is hidden in the ESP. But the fake one which is there as a new IP address will be shown to the intruders. So thus there is one point in this that the attackers cannot see to whom we are talking to. Like the host is communicated to some IP address. So that IP address we cannot see because we are hiding that and we are generating the new IP address which is a fake one. So this is done by the tunnel mode. Now coming to the transport mode. Here, as we are discussing direct communication from host A to host B, thus we need security in terms of ESP directly on the data, because here the IP address will not be hidden. Whatever the IP address is there will be shown directly. Thus, the attackers can understand like to whom we are connecting to, because original IP we are not changing anywhere. So the IP address is same as it is. Wherever the data, whatever we have, will be encrypted with ESP and AH concept. So ESP is nothing but encrypting purpose, whereas AH is given for the authentication purpose. And both will provide integrity for sure. So this is a job of both transport mode and also tunnel mode, right? So now authentication header, always we are saying we are utilizing ESP and AH. Now what is this AH and ESP? Now AH is nothing but authentication header where it is going to check with the authentication, thus who is sending the data to us, whose IP address is there as a source and to whom we are sending as a destination, right? So the source IP address will be signed and will be sending to the receiver. Now, the data integrity is also one of the services provided by the authentication header, where it is going to check with the integrity by means of checking whatever the data we received is correct or not at the receiving end. So thus we are going to utilize checksums whenever required to the original data. So the usage of checksum is the important thing here. And now, as we are utilizing authentication header, it can prevent address spoofing attack because address cannot be changed because we have sender data to be confidentially maintained. I mean, sender data to be authenticated, right, to the receiving end. So as a receiving end must have a proper sender data. That sender data we will be allotting in the authentication header, where this header will not be available to any other outsourced person. So thus the address spoofing will not be done. I mean, this is prevented by using authentication header. And as this is a thing which I was sending from sender, so this is one way only. And if receiver is about to send, now receiver will be called as a source. From that end, again, we will send in the authentication header. So this is protecting your data in terms of sender details. Means we are providing authentication as a sender details and integrity in the form of checksums. We are going to check all the data, whatever we have received at the receiving end. But the major difference, the disadvantage over AH is nothing but we cannot provide privacy to the data. Thus, we are moving to the ESP. So where we are giving data encryption also over there, which is not possible in the authentication header. Now let us see the authentication header format. See, header format is having what may be the next payload data. See, the next payload address information will be stored in the first block, and the payload length, whatever the data we are sending, the length of that payload will be given here, and reserved for the future purpose 31 bits like that, 16 bits. Now, security parameter index. So this index will be associated with the security association, where it will be having all the information of what are the cryptographic algorithms we have utilized, what are the parameters we are ongoing. So all this information about security associations will be given in the SPI, security parameter index. Now, what is this sequence number is? A sequence number is any incremented, I mean, one value which will be incremented all the time with every communication we are doing. So it will be just acting like a nonce also sometimes. So it will be an incremented value all the time. So if my sequence number is 1, if I'm utilizing this sequence, I mean header for the second time for the same communication, I will be giving this as 2. So that payload 1, I mean the packet 1 will be sent in first header, and packet 2 if I am giving, so sequence number will be changed to 2. So like that sequence number will be a counter value which will be incremented by 1 always. Now what is this authentication data is? The authentication data will be having the integrity check here. So whatever the sender sent data and received data is correct or not. So for that we are going with the ICV, that is integrity check value, or else we can provide the MAC of the existing packet at the beginning itself, right? So that we'll be checking integrity in a proper way. But the major difference distance here which we have with ESP is confidentiality. So for that confidentiality, we are moving to another thing that is called as encapsulating payload. So in the encapsulating payload, we provide confidentiality to the data along with from where the data is coming. So that is nothing but authentication and also integrity check of the data. So it will be reduced with the anti-replay service because we are going to utilize a nonce. So nonce is nothing but only once we can utilize that. So when we have one data which is having only once utilization, that is done with one OTP that is called as nonce, which is delivered only once and which can be created once and delivered once. Next, we have a security association also with this topology. Let us go with the ESP header. So in the ESP header, the major thing which we are going to concentrate is as SPI. So as we know, SPI is associated with the security association, which we are going to discuss in the next session. So next association will be having all the data which are related to the security terms like cryptography, integrity, authentications, and what are the attacks we may get. All those kind of data will be available here. Now, sequence number here in ESP plays an important role because it will be any value which is incremented by 1 all the time. At the same time, it will be acting as a nonce where it can avoid replay attacks, right? So now, next is a payload. See, whatever the payload we have may have the padding length and the next header and also the exact data. I mean, data, its length and upcoming packet data information. So everything we are encrypting that. So with one SPI index, some algorithm I may utilize this DDDS. So I will apply on this so that my data will be encrypted properly. Now, authentication data is nothing but who is sending the data. For this, I will be also having integrity check also here. So for the integrity check, we have anyhow ICV, that is integrity check value, which is computed through every packet, or else we can go directly with the MAC concept. So apply MAC on the given packet so that we'll get one MAC. That MAC we are going to analyze at the receiver end also. Right. So if you have any doubts in this, please be free to contact anytime in the college or through comments. Thank you for listening.